Hi everyone. This is the first video from a series of videos that we will upload to explain why Indonesian Muslims perform Fajr prayer way too early, whilst they perform Isha prayer too late. I represent the Islamic Science Research Network, IHAMKA in Jakarta. We have been conducting this research since February 2017, until now. The first comment we received before we published our report in early January last year: the result is not yet mature. How is that possible? This is the most comprehensive research on the beginning of the Fajr and Isha times. We use 4 types of sensors for detecting the presence of dawn. There are similar studies in Birmingham, UK, Libya, Egypt, and Malaysia. But, generally, the researchers only use 1 type of sensor. Besides doing this research since February 2017, we have collected the sky brightness data in Medan, Jakarta, Cirebon, Yogyakarta, Makassar, Labuan Bajo, and God willing, in the near future, we will collect data in Papua and possibly Aceh, so that they all will represent the political territory of Indonesia. The source of Sharia about dawn. The source of Sharia concerning the beginning of dawn in the Quran, among which is chapter 2, verse 187, which translates, "Eat and drink until it is distinct to you the white thread that is daylight and black thread that is darkness of night." The second source of law is the hadith narrated by Daraqutni, which translates, "There are 2 dawns. As for what rises into the sky, it does not hinder the early breakfast in the month of Ramadan, and does not justify prayer. If it has stretched, then it is haram for the breakfast, then pray the Fajr prayer." The following 2 photos show the differences between the 2 types of dawn described in the hadith above. The photo on the left shows false dawn, when the light rises upwards. At this time, we are still allowed to eat and drink during the month of Ramadan, because it has not entered the real dawn. Meanwhile, the real dawn appears if the light has stretched, so that we can no longer determine where the light source is. Whereas at the false dawn, the source of the light is clear. These are the provisions of the Prophet. Sun depression angle. This is the solar depression angle and twilight for general purposes according to astronomers for public usage. This provision is mainly for the needs in the world of aviation, hunting permits, regulations for car lights and street lighting, as well as tactical combat for American soldiers begin morning nautical twilight and end of evening nautical twilight. However, world astronomers argue that even the astronomical twilight is still considered totally dark for civilian purposes. This is what is meant by the astronomical twilight. This is a celestial sphere, and not a sphere representing the Earth. The Earth itself is a small point here. This is the horizon. When the sun sets, the sun's position is here. When the sun goes down by 6 degrees, this point is called the civil dawn. The interval between the local horizon and the civil dawn is called civil twilight. If the sun goes further down by 6 degrees, it comes to the nautical dawn. The range between these 2 dawns is called nautical twilight. Keep going down again 6 degrees, so that the total is 18 degrees from the horizon. This is what is called the astronomical dawn. This is called the astronomical twilight. It is this astronomical twilight that is considered by the world astronomers to be totally dark for civilian purposes. There are other astronomical provisions that must be considered. These 2 circles depict the celestial spheres which have an infinite radius of curvature. The Earth itself is just a small point in the center. While this is a zenith point, which is the point of intersection between a vertical line where we stand, with the celestial sphere. The latitude where we stand is the angle measured from the zenith to the equator. The picture to the left shows the zenith point of a high latitude point, while the right is at a low latitude. From the diagrams, we can see that the line TT prime shows the apparent solar trajectory at high latitudes is longer because it is more diagonal than at low latitudes. The problem is that Muslims in the world seem to have used sun depression angle dip, which tends to be random, to determine the beginning of dawn and its corresponding twilights, as we see in the following table. The Islamic Society of North America ISNA uses a dip of 15 degrees both for dawn and Isha. America is located at a latitude of about 47 degrees in the northern latitude. Meanwhile, Al-Qura University in Mecca uses a dip of 18 degrees, even though Mecca is located at a lower latitude, around 21 degrees. Even more peculiar is for Indonesia, Malaysia, Singapore and Brunei Darussalam, which are located at low latitudes around the equator. They use a 20-degree dip. As the apparent motion of the sun takes about 4 minutes to move by 1 degree, then the twilight in America is only 60 minutes, while in Indonesia 80 minutes. It is therefore clear, the provisions of various dips in the world are carried out without accurate astronomical studies. Perhaps, it is only done through rough guesses and is not in accordance with the very basic theory of astronomy. To examine the presence of more accurate dawn, we then use a sky quality meter to record the sky brightness data. Data is taken from around midnight until sunrise with a temporal resolution of 3 seconds. Therefore, from midnight to sunrise there are around 7,500 data. The two plots on the left are data that were taken on March 17th and May 24th, 2017, for dawn, while the right plots are data that were taken on May 25th and July 5th, 2017, for Isha. The value of sky brightness of 15 magnitudes shows the condition of the dark sky at around midnight. The drop in magnitude in the graph shows that the sky is getting brighter at around 3 a.m. However, it is not due to the presence of dawn, because the sky is getting darker again. The sky is really starting to light because of the presence of dawn on this arrow, because, beyond this point, the sky continues to grow brighter until the sun rises. The big problem, the official dawn according to the Indonesian government at the 20-degree dip on March 17, 2017, occurred at 438 as indicated by this vertical line. Even though the dawn actually should occur in the transition point between day and night. Likewise, the point of the disappearance of reddish rays, as a sign of commencement of Isha prayer, should occur here. So, it can be concluded that the Fajr prayer in Indonesia turned out to be too early, while the beginning of the Isha is actually too late. We have 198 data for dawn and 149 data for Isha, which all provide such indications. Automatic data processing. In order to be able to process the physical data from SQM recordings automatically, we develop a mathematical algorithm, because we have hundreds of data that must be processed. Each day, for dawn and evening, respectively, there are around 7,500 data. To automate this data processing, in a limited window, we can approach the SQM collected physical data with a polynomial function. Our next task is to determine the peak point of the polynomial function, which represents the presence of the dawn. We also calculate the deviation between the original SQM physical data against the polynomial model. This is called the root mean square error, which for all the data we have, the RMC is very good. Diagrammatically, at any point on the polynomial function, there will be a unique tangent to the polynomial. The slope of the tangent is d/dt. If this point continuously moves to the right, at a certain point, the tangent becomes flat where d/dt is 0. This is the point of the occurrence of dawn we are seeking. Beyond this point, the tangent to the polynomial continues to decline. Thus, if we refer to the last image when the tangent to the polynomial is horizontal, it occurred at 502 and with a root mean square error of only 0.01 magnitude. Thus, the value of dip or sun depression angle can be calculated by taking into account the necessary corrections such as the sun's apparent radius. From 198 data for the dawn, the average dip value is 13.29 degrees with a standard deviation of 1.85 degrees. Whereas from 149 data for the Isha, the average value of the dip is 13.34 degrees with a standard deviation of 1.59 degrees. These results are very reliable, because no member of the population exceeds the average value added or minus 3 times the standard deviation. Results that exceed the threshold like this are categorized as blunders. Conclusion. From 198 data for dawn, the real dawn has not yet appeared when the sun is at a dip of minus 20 degrees 80 minutes before sunrise. Instead, the statistics of the real dawn appears at dip minus 13.3 degrees, or about 53 minutes before sunrise. Of the 149 data for the Isha, the reddish ray does not disappear when the sun is at dip minus 18 degrees, or 72 minutes after sunset. Instead, it has disappeared earlier when the sun at dip-13.3 degrees, or 53 minutes after sunset. Meanwhile, Hassan obtained a dip for dawn at minus 14.7 degrees or the range of twilight of 59 minutes before sunrise in Libya and Egypt at a latitude of 32 degrees. Hassan's results turned out to match the theoretical astronomical diagram which says that twilight in the higher latitudes like Libya and Egypt should be longer than in low latitudes like Indonesia. See these two diagrams. Thanks for watching.